Welcome dear students. Today we are going to see Verilog description for 4-bit comparator. Comparator is a device. We know it will compare the bits whatever we are giving as input. Now I will give you a brief description about the comparator. Comparator. It is a block. It is a device which takes input and it will compare the inputs. And it will give us three types of outputs, whether A is greater than B or equal to B or lesser than B. This is a basic logic of the comparator. So, how many bits we are using? According to that, the comparator may vary. The process, the operation will vary. See, here we are using 4-bit comparator. Means A input I am giving 4 bit, B input I am giving 4 input. So, while comparing these two, A in and B in, we are getting the outputs in the form of greater than, equal to or lesser than. So, we will see the truth table according to that. For example, if I am giving A in 4 bit as 1100 and B in is 0011. If we compare these two, this comparator will give us greater than symbol as 1 because A in value is greater than B in, isn't it? This value is greater than this one. 1100 is nothing but 12. Yes. So, this is nothing but 3. 12 is greater than 3. That is a decimal equivalent for this number is 12 and decimal equivalent for this number is 3. So, 12 is greater than 3. So, greater symbol will be highlighted. That is A in is greater than B. In that scenario, the bit will highlight. So, remaining it doesn't equal to this. So, 0. It doesn't lesser than this. So, it is also 0. Next. 0110 and 0110. Decimal equivalent is 6. 0110 is 6. This is also 6. Yeah, 6 is equal to 6. So, under equality sign, the output we will get as 1. Remaining everything is 0. Next, 10001110. This is the basic, the decimal equivalent for this is 8 and decimal equivalent for this is what? 1110. What is the decimal equivalent? Yes, 14. So, this is greater than this. So, automatically this is lesser than this. So, A in is lesser than B in. So, lesser than symbol will highlight it. It is not equal. So, 0. It is not greater than this. So, it is 0. This is a basic mathematical concept. Just we are comparing the inputs. Two inputs we are giving as an input and that inputs is compared with each other whether it is greater than or equal or lesser than. This is simple mathematics what we did in our basic mathematics studies. Yes? If any two numbers if they give, we are comparing that. Either it is greater than or lesser than or equal. Only these three concepts is there to compare any two numbers, whether it may greater or equal or lesser. In the same way, in the binary world also, how many bits, whatever may be, irrespective of the bits, if you given the inputs, it should compare. The comparator should compare and should enable the pins greater, equal or lesser. Here we are discussing about 4-bit comparator. So, we are giving 4 bits as our inputs. Now, this is a basic concept of 4-bit comparator. Now, our task is how we are going to write the Verilog code. That too in data flow modeling, how we are going to write the Verilog code for this operation. Okay. Module is a keyword as I told you. Module come. This may be any name, any file name you can give. This may be any name. The file name what you save that you can give. So file name. Here we have 5 types of codes we are using here. A in, B in and greater than, equal to, lesser than. These 5 things we are using here. In that these 2 is input and these 3 is output, isn't it? These 2 is input and these 3 is output. So, input. So, once again I am giving you clarity. Here we are using 4-bit comparator. So, we are using 4 bit as input. So, how many, here it will shows how many bit I am taking as input. Yeah, from 0 to 3. 0, 1, 2, 3. From 0 to 3 I am taking. Here also 0, 1, 2, 3. So, 0 to 3. A in, B in. This is my input and output is either it may be greater than or equal to or lesser than. So, output is greater than, that is then I represent it with the help of capital letters. You can give any names to represent the outputs. So output G, output E, output L. Now we are going to store only the outputs, not the inputs, right? We are going to store only the output in register. So reg, G-E-N, G-E-N. I hope you understood till this. This is an initial declaration. Now, always. This is a normal word we are using in data flow modeling. It is nothing but always at, where we are changing the values. Only the input, not the output, right? Only the input we are changing the values. As per this input variation, we are getting the output. So always at A in comma B in. I may change A in or I may change B in. So now I am starting my process. Begin. Always, after always, I should begin the process. Begin. If we have three types of condition, right? Either it should be greater than or equal to or lesser than. So begin. If A(n) is lesser than B. If I am giving this value, it is lesser than this. If A(n) is lesser than B, lesser symbol will be activated. 1 beta 0. Else, if it is not satisfied, it will give us 0. Again, if A(n) is greater than B(n), if I am giving A(n), this value is greater than this, my greater output will be activated. 1 bit, 1, like that it will come as output. Else, it will be 0. If A(n) is equal to B(n), my equal to is equal to 1 bit, that is 1, it will be displayed. That means if A(n) is equal to B, that means this is equal to this, then equal to symbol will be highlighted. Remaining everything will be 0. Else E is equal to 0. Everywhere it is E is equal to 0. See, if it is equal to only, it will highlight. Else everything will be 0. Next. And for this begin, we are ending here, and for this module, we are ending end module. In this way, we can construct our own program in VERILOG description. Here, I explained in data flow modeling. We can write in behavior, structural, gate level also. For comparator, by simplifying this truth table, you can construct your own logic diagram. So, as per logic diagram, which gates you are getting, by using that gate, you are using structural flow model to write the VERILOG description. So, in this way, we can construct our own VERILOG program for any type of digital devices. Thank you, students.